So today we're looking at something called optimization, and one way to do it is by using delsdebt. So delsdebt is an acronym for standing for different parts that you need to do. Write all the letters down for delsdebt, and this puts in order what you need to do to be able to solve optimization questions. So the first D stands for draw a diagram of the problem if possible. Sometimes it's not, and sometimes they give a diagram to you. E for express a problem that needs to be maximized as an equation or minimized. Link the two variables in the expression, and we're looking for another equation that will link these two variables together. S for substitute, so we've only got one variable to be able to differentiate it. D for differentiate. E for equating to 0 so you can find maximum and minimum. B for back substituting, so we're going to put it back into the original problem to find the maximum or minimum value. And T is for testing your answer, checking to see that you've answered the question. So we're looking at this question here. The farmer uses 300 metres of electric fence to form a rectangular paddock, and he's got an existing fence. What dimensions should he construct his paddock so to maximise the area? So the first D is draw a diagram of the problem if possible. So we're going to draw that diagram. We've got a fence already, and we're going to draw our rectangular paddock around it. And we know that that equals 300 metres. So we'll just put that diagram out to the corner, looking at it bird's eye view. So our next letter is E, and that stands for express the problem that needs to be maximised or minimised as an equation. What you can see here is that they're asking you to maximise the area. So first of all, we need a formula, so to speak, to find the area of the paddock. Nice rectangle. So our area is x times y, so we'll put our x in and put our y in. Unfortunately, we can't differentiate that because we've got two variables. We've got x and y. So our L stands for linking the two variables in the expression with an equation. So we're looking for another equation that will link the two variables. And what we were given is that we knew that we had 300 metres of fencing available. So we're only looking at it on three sides. So that's why we've got 2x plus y equals 300. We don't need to do the fourth side because it's already a fence. So our S stands for substituting, so there's only one variable in the expression to be maximised or minimised. Now remember that we want to maximise the area, so we're going to replace either an x or y back in the area equation. So we know from this equation here that y equals 300 minus 2x, just rearranging it. And so now we can change our area to being x times 300 minus 2x. And we can just simplify that as being 300x minus 2x squared. So we've got the area being that. So we can differentiate that now because we've only got one variable. So our A dash is 300 minus 4x. Now our E is put it equal to 0. So we take our A dash and put it equal to 0. So now we've got 300 minus 4x. Solve, move the 4x over to that side, and we get 4x equals 300, and then divide by 4, and we get x as being 75. Now our B stands for back substituting. So we're going to find the maximum or minimum value. First of all, we have to find out what our y is. So we know x is 75. We also know that y equals 300 minus 2x. So we just substitute our x in, and we get y being 150. So the last T stands for test your answer. Have we answered the question? So we've got our y being 150. The question asks for the maximum area, so I need to find the area. The area is x times y, so we just times 75 by 150 and we get 11,250 square metres. Here's another question that we've got. So we've got a rectangular sheet of cardboard is to have 4 equal corners removed and the sides turned out to form an open box. If the cardboard measures 18 centimetres by 10 centimetres, find the lengths of the edges of squares to be removed to maximise the volume of the box. So first of all, we're going to do a diagram. Okay, so this is our piece of paper. We know that that whole length along that side is 18, and the whole length of that side is going to be 10. So we're going to let the little corners to be taken out being size x. So that means this part of it has to be 18 minus 2x. And if we go up this side there, that's going to be 10 minus 2x. So we need to write an equation. That's just it folded up. So the front of it's going to be 18 minus 2x. The height of it is x. And our width of it is going to be 10 minus 2x. Our volume is our length times width times height. And so we can just times all of those together. If you notice in this one, we've actually only got one variable. So we don't need to link up the equations or use some other information. But what we do need to do is expand it out. And so when we expand it out, we get 4x cubed minus 56x squared plus 180x, just by using your FOIL and then timesing everything by x later on. So now that's ready to differentiate. So we've got v dash equals 12x squared minus 112x plus 180. You can put that into the graphics calculator to solve after we put it equal to 0, because remember, to find maximum or minimum we put it equal to 0. And we get x being two numbers, 2.063 or 7.270. We can double differentiate to find out whether it's a maximum or minimum. However, we can also know that this one is actually impossible. So there's our v double dash, but we know that 7.27 is impossible, because if we have a look at x here, if we had two x's being there and there, both being 7.270, that would be bigger than the 10 centimetres that's already there. So therefore there is only one answer. This is actually looking at it when it's maximum or minimum. But we know that it's impossible when it's 7.270, so we know that x has to be 2.1 centimetres. And it just said find the length of the edges of the squares to be removed. So we just find our x is 2.1 centimetres. And that's doing optimisation.